Hello and welcome. To find the real values of x that satisfy this radical equation, let us call this quantity u and let us call this quantity v. Now with these two substitutions, you will see that the original equation is now u plus v is equal to 6. And of course, if the fourth root of 386 minus x is equal to u, then that means that u to the power 4 is 386 minus x. And likewise, if the fourth root of x is equal to v, then v to the power 4 is equal to x. Now look at these two equations. Here we have minus x and here we have plus x. So you will see that if we add this equation to this equation, we are going to be able to eliminate x. And we will have that u to the power 4 plus v to the power 4 is equal to 386. So now we have a second equation in terms of u and v. We have u to the power 4 plus v to the power 4 is equal to 386. Now what we are going to do is to solve these two equations for values of u and v. And from there we can get the value of x that satisfies this radical equation. But to solve these two equations, we must find a way to write this second equation in terms of u plus v and uv. Now let us recall the algebraic identity. A squared plus b squared is equal to a plus b squared minus 2ab. If we write this second equation as u squared squared plus v squared squared, then the right hand side is going to be equal to u squared plus v squared minus 2 times u squared times v squared. But then look at this bracket. Once more, you will see something that looks like this. So we can still expand this. When we do that, we have u plus v squared minus 2uv all squared. Then we have minus 2u squared v squared. Now let us expand this. We have u plus v squared squared. So of course that is going to be equal to u plus v to the power 4. We have 2 times this. That is minus 4uv multiplied by u plus v squared. And then we have minus 2uv squared, which is going to give us plus 4u squared v squared. Then of course we have this term, which is minus 2u squared v squared. This is 2. So from this line, we can safely say that u to the power 4 plus v to the power 4 is equal to u plus v to the power 4 minus 4uv multiplied by u plus v squared. And of course, 4u squared v squared minus 2u squared v squared is going to give us plus 2u squared v squared. Now you can see that we have expressed u to the power 4 plus v to the power 4 in terms of u plus v and u times v. But then let us remember that u to the power 4 plus v to the power 4 is equal to 386. So here we have 386. Let us also remember that u plus v is equal to 6. So here we have 6 to the power 4, which is 1296. U plus v is equal to 6. 6 squared is 36 times 4. That is 144 uv. And of course, we can write this as 2 times uv squared. Now, when you look at this equation, you will immediately see that we have a quadratic equation in uv. Let us take everything over to the right-hand side. When we do that, we have 0 on the left-hand side. Now, 1296 minus 386 is going to give us 910 minus 144 uv plus 2 uv squared. Let us divide this equation by 2 to reduce the numbers we are dealing with. When we do that and rearrange, 2 uv squared divided by 2 is uv squared. Minus 144 uv divided by 2 is minus 72 uv. And 910 divided by 2 is plus 455. And everything is equal to 0. Now we can factorize this equation. All we have to do is to find the factors of 455 that add up to minus 72. And of course, they are going to be minus 7 and minus 65. Because minus 7 plus minus 65 is going to give us minus 72. And minus 7 times minus 65 is going to give us plus 455. So we can easily factorize this equation as uv minus 7 multiplied by uv minus 65 is equal to 0. And from here we have that uv minus 7 is equal to 0, or uv minus 65 is equal to 0. And of course, uv is equal to 7, or uv is equal to 65. So now we have reduced this original system to two systems. That is, we have u plus v is equal to 6 and uv is equal to 7. Or u plus v is equal to 6 and uv is equal to 65. Now you can see that these two equations are much easier to solve than this and this. Now to solve these two equations, we start with the first set. From this first equation, we have that u is equal to 6 minus v. Substituting this into the second equation, we have that v minus 6 minus v is equal to 7. Expanding this, we have 6v minus v squared is equal to 7. Rearranging this equation, we have v squared minus 6v plus 7 is equal to 0. Now we cannot factorize this equation, so let us complete the square. First of all, we move the constant term over to the right-hand side. So we have v squared minus 6v is equal to minus 7. Then next, we add the square of half the coefficient of v to both sides of the equation. Now, the coefficient of v is minus 6, so half of it is minus 3, and the square of that is minus 3 squared, which is 9. So we are going to add 9 to both sides of this equation. When we do that, we have v squared minus 6v plus minus 3 squared is equal to minus 7 plus 9. Now you can see that the left-hand side is a perfect square. So we have v minus 3 squared is equal to 9 minus 7 is 2. So taking square root of both sides of this equation, we have that v minus 3 is equal to plus or minus square root of 2. And of course, from here we have that v is equal to 3 plus or minus square root of 2. Now we come back to this equation to find that u is equal to 6 minus 3 plus or minus square root of 2. we have that u is equal to 6 minus 3 minus plus square root of 2, which is equal to 6 minus 3 is 3 minus plus square root of 2. Now, what this means is that when v is equal to 3 plus square root of 2, u is equal to 3 minus square root of 2. And when v is equal to 3 minus square root of 2, u is equal to 3 plus square root of 2. The 2 points are a reflection of each other. Now we move on to the second set of equations. Once more, we have that u is equal to 6 minus v. Substituting into this, we have that v, 6 minus v is equal to 65. Expanding, we have that 6v minus v squared is equal to 65. Rearranging this equation, we have v squared minus 6v plus 65 is equal to 0. This equation does not have real roots. Let me prove that to you. We have the discriminant, which is b squared minus 4ac. b is minus 6. b squared is minus 6 squared, which is 36. We have 4, we have a, which is 1, and we have c, which is 65. Now, it is obvious that 4 times 65 is greater than 36. So this quantity is going to be less than 0. It's going to be negative. And of course, you know that when a quadratic equation has a negative discriminant, then the quadratic equation has no real roots. So we are not going to use this equation to solve this problem. The only real roots we have are v equal to 3 plus or minus square root of 2 and u equal to 3 minus plus square root of 2. Now from this substitution, we have that v to the power 4 is equal to x. So that means that the values of x that satisfy this radical equation are x equal to 3 plus or minus square root of 2 to the power 4. And with that, we come to the end of today's exercise. I hope you learned something new. If you enjoy such content, please subscribe to the channel. Thanks for watching and see you in the next one.